start them out? Either way. All right, so you guys are supposed to FOIL that guy, and when you FOIL that guy, hold on, check it. Did you eventually get, not killing a puppy, I really hope you have 3 terms and not just 2 terms. If you have 3 terms, you FOILed it. If you had 2 terms, you killed a puppy. If you FOILed it out, you should have gotten 25x to the 4th times 10x. Well, I guess that 10 we could technically pull out and not even deal with. That'd be nice. I'm going to end up with 25x to the 5th, I believe. And then plus, here's the 5x squared is 10x squared, 10x cubed would be the next term. Or you might have gotten 100x cubed, or 250x to the 5th if you kept that 10 in there. And then we have a plus 1 times an x, or it could have been a 10x. Double check how you multiplied it out. Did you get to the right rewritten form?
Okay. Kind of. I mean, it was a little different, but...
Was it 250x to the 5th plus 100x cubed plus 10x?
Yes.
Perfect. So then you can just pull the 10 out, or you can leave it in, either way. But eventually, we have to take the antiderivative. Now, once again, if you only have 2 terms, I bet you said, squared. I really hope it works, and it never does. So that's FOIL.
If it's subtraction.
FOIL. What?
If it's subtraction.
Nope.
No?
3 terms of subtraction. If it's a positive and a negative, that can never be written as a squared and multiplying a difference of squares. Then.
Yes.
Oh dear. You go take the derivative, antiderivative. You end up with 25 over 6 x to the 6, or 250 x to the 6 over 6, if that 10 is multiplied in there. Then we end up with, you guys keep going, I don't need to tell you this. What's the next term? X to the 4th all over 4, or 100 x to the 4th all over 4, which I guess would be 25, or this one would be
25 x to the 4th.
Nice. And then this one could just be x squared over 2, or 10x squared over 2, which is the same thing as 5. Don't forget your.
Plus the...
Okay. Do you have a form of the right answer? Yes or no? Okay. How horribly bad was that?
Yeah,
Was it possible?
Yes.
Yes. Was there some foiling, like beginning algebra 1 stuff that could have gone wrong?
Yes.
Yes. Yes. Were there some places that the power rule could have gone wrong? Yes. Is anybody just hearing how I introduced class? Just hearing how Adam was like, why is it called old school? Don't you just multiply? And I said, yeah, I multiply, but he was still stuck on the old school. It's because you're able to come into class today and do this problem, or you should have been able to come into class today and do this problem. So why is it in a new section of a new chapter, or a new part of the chapter? My question is, do you see a U? Do you see a U?
Yes.
Is there another way of looking at this, and instead of just saying like, ooh, we got to get everything in terms of x? Is there a U? 5x squared plus 1?
Yes.
Could that be a U?
Well, I just see it in everything in the bottom.
Oh, you see a 5x squared. Okay, dangerous, stop. U came from U sub, talking about derivatives, was derivatives of compositions of functions, f's of g's of x, aka f of u's, aka something inside an argument of a bigger something, a bigger function. Do you see something inside? The answer is hopefully yes. But the problem is, this is not a function we're taking a derivative of. Oh, hey, 2u times u prime. U prime. U prime. Maybe. U's prime. Oh my goodness, I'm looking at the derivative and there's a u prime. Wait a minute. If there's a u prime, is there a way to deal with this? Okay. Maybe that's a little too much. Hold on. Okay, there you go. Goal, a new technique for integrating complex functions. Okay. In math, complex has a very imaginary meaning, right? So let's take away the imaginary meaning and let's just call it what it is, a synonym that does not have more than one meaning. There we go. A complicated function. That's better. That's the first time I've ever actually thought about that. Not complex and imaginary math. Okay, yeah. Complicated. New techniques for integrating complicated functions, and more specifically, integrands that could have, would have, looked like their compositions. Integrands that seem to be compositions that seem to have u's. Now, here's the dilemma. If we're looking at the integrand, that's a derivative of something. You want to think about it in terms of capital F's prime, F being the antiderivative. So it's not just going to be the composition. It's not just going to be the derivative of the composition. It's going to have a u prime, or if it doesn't, it needs to have had a u prime. It's a bit of a struggle because up until this point, those basic antiderivative rules are like, hey, whoever's inside is the derivative of something. Who is he the derivative of? Integral of cosine. Yep, it's sine of x plus c. Integral of secant squared. Yep, it's tangent of x plus c. We've gone strict rules backwards. Or even if it's something weird like tangent squared of x, we say, oh, there's a Pythagorean property that makes it secant squared of x plus 1. Now we can integrate. Which I did not give you one that bad on the test, although there was a 1 minus cosine squared sine squared. Bonus. But now we're going to see things that are not quite so straightforward. And they weren't before. There were radicals that you had to make into powers. And there were denominators that you had to split up or make negative powers. There was multiplication that had to happen before you could anti-derive. But now there's going to be a composition of functions. And the only way to go backwards, remember, every derivative rule can be rewritten as an integration rule. In order to go backwards from this guy to that guy, we're going to have to not only see this as a derivative, but also find or see this as a u prime. So here's the weird part as I zoom in. If every derivative rule can be rewritten as an integration rule, how would we rewrite these derivatives? Well, here's one way. Now check it. Now check it. I'm not starting with an initial lowercase f and finding f prime. Bless you. I'm starting with a lowercase f inside an integral and going back to its antiderivative. So remember, little f just means that's what you're starting with. First semester, we were starting with functions taking their derivatives. Second semester, we're starting with integrands for the most part and finding their antiderivatives, starting with rates and going back. But check it. I've just taken the chain rule and said, okay, well, if this is my function, if he has a u inside, and if there's a u's prime, I can go from that back to who he was to begin with. So little s antiderivative, okay, undoing whatever this is of g of x, but the weird part is, in a sense, this disappears. Now, technically, to be honest, the dx has always disappeared. Some of you have realized that. Some of you have struggled with that. And you're still struggling with that. The dx disappears. Some of you might have wondered why the dx disappears. So far, I've just said it. The dx is like a bookend. I have the integral on this side, the dx on this side. Everybody in between is what I'm trying to anti-derive. But maybe once we learn the chain, there is no chain rule of integration, lo siento, but there is u sub that lets me deal with what integrands came from chain rule. Working backwards to compositions. Maybe we'll finally understand why that dx is there. And to be honest, I don't think I've actually ever shown that before, so this could be interesting. Why the dx is actually there. So, what if we were to re-look at this guy a different way? What if we were to look at this guy a different way? Instead of saying, okay, we have to move forward, and moving forward is using those basic antiderivative rules, and to do that, I have to multiply first. With me doing this weird kind of gloomy foreshadowing of what if it was a cubed or a fourth power. I don't want to have to multiply every time. Let's instead look at this as, I think this might have come from a chain rule. Why is it called integration with u sub? Because literally, let's not make it yellow, that's awkward. We are going to take a second to analyze what we've been given, not just rewriting it, not just multiplying it, not just combining like terms, etc., but to analyze what we're looking at. And I'm going to say, kind of like some of you thought or said, what if the u is the inside? What if the u was and still is the inside? What if u was or is the inside? Now, if that's true, check it. Couldn't we substitute and say u squared? But what else is there besides the u who's being squared? Don't I have a 10x dx also? I can't take an integral of an integrand that's in terms of any other variable than what's in this differential. Another way of saying it is I can't take an integral of a mixture of variables. So you guys saw in your homework stuff with y's and dy, stuff with u's and du's, stuff with x's and dx, maybe even stuff with t's and dt. The struggle is right now I have stuff with u's and x's dx. What is this supposed to be in terms of, technically? X, and that's how it started. But I'm transitioning, trying to get it in terms of u. Now, how do I get rid of the dx?
Integrate it?
Not integrate. Well, yes, if I was able to, but we're assuming or we're trying to go about doing this a different way other than multiplying. So right now we can't unless we look at it differently. And the way to look at it differently is in terms of u. So instead of trying to get rid of the dx by integrating, which I'm like, I don't know how, where does dx come from?
dx.
dy dx. So in this one, it's not dy dx, it's du dx. Who would du dx be? Oops, I just wrote dy. Isn't du dx the same thing as u prime? Who is u prime? Can't I take this and can't I multiply? That's why they showed us that at the end of the semester. Can't I multiply this to the other side and say du is equal to 10x dx? I just split up my differentials like we saw we were allowed to do at the end of the semester. And to be honest, we're not going to really write this very often because it's kind of more of a parenthesis once we see, oh, hey, we're just going to do du dx, but then move the dx over here. And now I'm going to try to match. Now, sometimes it matches perfectly like this one. Most of the time, it doesn't match perfectly. So to prepare you for the most of the time, I'm actually not going to just go straight down and plug in du, even though I could. I could do a strict substitution right now. And I could say, oh, hey, you guys are equal, sweet, 10x dx, you get out, du, you get in. However, I'm not going to do that to prepare you for harder problems. Instead, I'm going to say, you know what, that dx guy, totally illegal to stay if I'm trying to look at this integral in terms of u. So we're going to take this and we're going to go ahead and solve for dx. Let's just put it this way. That nice 10x, that nice u prime is not always there, but the dx will always be there. So I solve for what is there, will always be there, and I plug it in, plug it in. But what's really nice when I plug it in, plug it in? The 10x goes away. So I end up with u squared times 10x times du all over 10x. Those reduce away. I just have, and some of you might have seen that even earlier, u squared du. Oh my goodness. All we have to do is a power rule. What's the integral of u squared? I'm done. Nah. It was in terms of x to begin with. This is in terms of u. I have to clarify. I have to finish my thought and say, I thought about it in terms of u. Who was u?
Wait a minute.
Now some of you are like, wait a minute, we just solved this, and those answers look very different.
Well, because you can get to the 125 divided by 3.
That is 250.
125.
Nice. Because couldn't a 2 come out from everybody, right? If I multiply by 10 over 6, that would end up being 3 and 5, and that would be 2 and 5, and that would be 1 and 5, so I could do it that way. And then isn't 5 and 25 125, which is going to be 5 cubed over 3? Oh my goodness. Are they the same? Question. Which one looks more like an AP answer? This one or that one?
That
one. This one is more simplified. So here's the struggle. Give me oh, power rule. U to the n plus 1 over n plus 1. Yeah. And then remember, double check the derivative, bring down the 3. u squared. Here's the struggle, guys. Could you have solved it by multiplying out? The answer is yes. Would you have been able to make it match? I don't know. Can you do the cubic factoring? Wait a minute. This doesn't make any sense. In order to have that, shouldn't there be a constant? Right now, I could pull out an x squared, and that's not going to match. Don't you guys see you can pull out an x squared?
Yeah.
So it doesn't match?
Yeah.
Oh, we were on such a good trajectory. Like, I don't understand. Why doesn't it match? Hold on. How can we know whether or not it matches? We can know whether or not it matches if we actually multiply it out.
Oh boy.
Pascal's triangle. No stress. I got this. Pascal's triangle. We have a 1, we have a 3, we have a 3, we have a 1. Because it's something that's been cubed, right? Problem is that's there kind of out of room for you guys. Here we go. Let's move that. Let's move that. Oh my goodness. Nope. Let's not do that. We're not going to do that. Okay. Undo. 1331. Binomial theorem from pre-cal. Unless you guys really want to go like squaring and then doing a polynomial multiplication thing. We're going to end up with, the first guy's cubed. So 5x squared cubed. The second guy to the 0 power. He's gone. And then we have 3 times the binomial coefficient, Pascal's triangle number, times 5x squared times 1. Okay, 1 to the 1, that's easy. 3 times 5x squared to the first times 1 squared, that's still 1. And then 1 times 1 cubed, still 1. So then we do get that 125x to the 6th, and we get that 25 and 3, 75x to the 4th, and then we get that 15x squared, and then we get that plus 1.
Isn't it 1 times 3 again? Oh, no, never mind.
I think that's right?
Yeah.
Wait a minute. How does that compare to the guy that we solved over here?
First you get that 3 out.
Yeah, it gets a little bit sticky, right? So if we distribute that 3, it'd be 125 over 3. Okay, wait a minute. We have that, right? And then it would be 75 over 3. Well, we have that. And then it'd be 15 over 3. Well, we have that. What on earth? He needs a 1/3.
That's it.
He has them. He has anybody you want. He has everybody you want. But here's the struggle. Would you be able to factor this to make it look exactly like that if
No.
C can be infinitely anything? No. So do we need to learn U sub? Yes. Otherwise you won't be able to make it match even if you do it the hard way. So U sub. Here we go. When you zoom in, U sub. But hopefully at least some of you realize U sub looks a lot easier if we could just get the hang of it. Hopefully. U sub. Let U equal the inner function. Choose wisely. Don't worry. Wisdom comes with experience. And direction, hopefully. And a solid grasp of truth. Choose wisely. Don't worry. We'll build that. We'll build the wisdom. But U has to equal the inner function. We're kind of used to inner functions, and some of you guys even did a great job of who was the inner function in the example, 5x squared plus 1. Why? Because he was inside. Okay. Remember the Matryoshka thinking who would have been inside. Find du. Now, okay. Don't stress. Remember, u prime is du dx. So you're really just doing u prime and multiplying dx, so it helps. You can think every time du is u primes or u prime times dx. That helps. We're going to jump straight to du, which will be u prime times, times dx. My voice still has this weird, doesn't want to work. Okay. Rewrite the integral in terms of u and du. What does that mean? Good old-fashioned substitution. I'm going to write it in green. That's so old. Substitution. Pre-cal right now is doing like systems of equations with substitution. About to be elimination. About to be row reduced echelon form. About to be matrices.
Oh, they're going to matrices?
Close.
That was the best part. You had to make it stronger through vectors, and then we got row echelon. Those are the days. Junior year.
Some people like them. Some people never like them. U sub, that's number 3, U sub, but not just U sub, du sub 2. You gotta use both. You gotta get rid of all the x stuff, and you gotta get rid of the dx as well. So ultimately, how do we get du? What we're going to do is ultimately, for our substitution step, we're going to have to solve this guy and be like, okay, dx, who are you? Because you're always in every integral, always in forever. We're going to take whatever we get here, solve for dx, and we're going to use that for our substitution step. Getting rid of the dx and getting in the du. That's kind of how we're always going to do that du step. Some of you might start to, as you get the hang of it, do some mental math and go a little bit quicker, but just to be safe, we're going to show the work. Step 4 is find the antiderivative in terms of u, like we just did, 1/3 u cubed plus c. Step 5 is replace u with its function, get it back in terms of the original variable, x or t or theta or whatever it was. And then a remember. Ooh, a remember.
Do you remember?
Totally just had that song in my head. That's funny. Pussy! You're welcome. Yeah, I know. A little anticlimactic, but that's okay.
Anticlimactic.
Pussy needs to build up because otherwise you guys forget him. Poor guy. Maybe some of you are like, you should make that a forever. Maybe, but I really just need you to get it down like chain rule to where you just start seeing it and doing it. And I don't really need you to know word for word exactly the way I put the steps. I just need you to know the process and be able to do it legally. Yeah.
I have an analogy for C. Oh my gosh. So C is like a friend that never gets invited anywhere, but is needed in the friend groups because he's so important.
Would you rather be wanted or needed though?
No? There's would you rather want or
I think you know everybody would naturally want more, but if you have to settle for one, it's like, well, it's a sad outlook, but it's more important.
But he's needed.
What would everybody ideally want?
Well,
If
no,
I
I
cut
see.
someone off, they would cut you off.
Everyone forgets about him, but he's needed. Plus C.
I think we could just remember.
Let's go back to the song. Okay, so that analogy could be maybe a little bit better, but I see what you're saying, and it's understandable. In that you're trying to be like, man, we always forget him, but we need him. When u prime fits exactly. These first examples are like nice, perfect, neat, straightforward. Don't worry, the messy ones are coming. Speaking of messy, that was the messy analogy, and yet, to be honest, true to life. Oh. Who's you?
Squared.
What's inside? What's inside?
Minus
Inside.
10.
U equals x squared minus 10. Who's du?
Oh, du? Oh, du.
Who's du? Remember how we find du? Look at your steps if you need to. We take u prime. So who's u prime?
2x?
2x, and we multiply it by
Yes.
dx.
Okay, I have a question.
Wow, that makes everything better. Adam.
If we're always going to be replacing dx, like plugging in, why do we find du first?
Because we are choosing the u.
I choose you.
Exactly.
When we like,
And so the du's will be what's changing. The dx always stays the same.
so can you write it as like dx equals du over u prime instead of like this step?
Yes, but some of the u primes get pretty complicated, and so then you'll have complex fractions when you could have just had it. See what I mean? You could have a du over a complex fraction instead of a fraction where you can multiply and divide and get that nice reciprocal easier. So ultimately simplifying life for the harder u primes. Got it. Okay, so now that we have this, Adam is already taking the next jump because he's like, wait a minute, hold on. I'm telling you guys to get dx by itself. So he's saying, well, why not just do dx is always equal to du over u prime, and I'm warning him that not all u primes are as nice and neat and pretty and simple as this u prime, which was just 2x. But all we did was divide, or I should say isolate dx. We isolate dx. So dx is equal to du over 2x, no big deal. Why did we do that? Well, because we have a dx to plug in for, and then we have other stuff that hopefully will just kind of resolve themselves as we go plugging in u. So let's go ahead and plug and chug, and what we end up with is the integral of 2x times the square root of u times du over 2x. Why is this called when u prime fits exactly? Because what is about to happen? Everything goes away except for all the stuff with u's. U prime fits exactly when you could have just expanded your reach a little bit and said, oh, hey, look, it's du. So I have the square root of u du. Not all that nice, they're not all that neat, they're not all that simple. But if u prime fits exactly, everything goes away just like it should, and we end up with a nice little u to the 1/2 du, which I can anti-derive to be u to the 3/2 times 2/3, and I can get that who is u right back on in where he belongs. Which we know you could write that with like a square root, or you could write that with a 1.5 powers. We could do some other stuff, some other crazy stuff. What you can't do is bring in the 2/3 because of order of operations. Oh, let's go back to pre-algebra and middle school math. What's the order of operations if you were to plug in the number and actually start solving? Parentheses, exponents, and then what's the very last thing you'd be able to do? Multiply. Well, then add. Oh, I anti-derived. Yeah, u to the 3/2 times 2/3. And then I plugged in my u. You right. Just kidding, too much. Okay, sorry. Okay. Writing out what I did before my u step. I know, I'm sorry. I teach CalcAB. We've been doing these mental math all year. No. I'm apologizing. I'm apologizing. I have u to the 3/2 because it's plus 2 over 2, dividing by 3/2, which is multiplying by the reciprocal, and then plus c, and then I bring in the u. Got it. Now, number 2 is ironically also a very nice one, although it's a very tricky one. Because didn't you guys just see some nasty trig something on the bonus of yesterday's test? Wasn't the only way to move forward with that using your transforming skills and bringing in old trig identities and substituting maybe a
It was cosine cubed.
Oh, you didn't have the tangent.
2 minus.
Over 2 minus 2.
We had to back it out to 2 and seeing 1 minus sine squared to be cosine squared and cosine cubed over cosine squared reduced. So really it was just 1/2 cosine, which has an integral that we know. You might look at this and be like, oh man, it's a T-proof, I gotta start playing. But actually, really, I don't mind this kind of scariness as long as I realize my u is tangent. What? Wait.
Did you just?
Wait. What? How did I choose tangent? Well, a lot of experience and a lot of wisdom based on a lot of prior problems that I've done. But don't worry. Just see if it can make sense why I chose tangent. Who would du be? Who's u prime? Secant squared. Ooh, we're going to be practicing our derivatives as we find our u primes. That's kind of nice. Always good to remember what we're supposed to already know. Who's the derivative of tangent? Secant squared. So if I was to solve for dx, I would get du over secant squared. Is this secant squared something for me to be worried about?
No.
Absolutely not. Because when I go to plug in, come up here and say, hey, I got a dx, I'm going to plug that in. And then like, oh, I have a place for a u, I'm going to plug that. Undo. I already have tangent. I'm going to plug that in.
Reduce.
Anybody see I'm just going to end up with u cubed? So u cubed, because it's who cubed? Tangent cubed. U cubed. And then I have secant squared of x, which seemed so scary a second ago, until I plug in my du over secant squared of x. My secant squareds end up reducing away, and all I have is the integral of u cubed du, which is as easy as 1/4 u to the 4th plus c. But who is u? So it'll be 1/4 tangent, remember your snazzy notation, to the 4th of x. Let's see. If you don't believe me, check me. How would you take the derivative of 1/4 u to the 4th? You would bring down the 4th, that's gone. it'd be u cubed tangent cubed times u prime, which is secant squared. Dun, 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 dun.
Wait.
Yeah.
So since u is tan and then the derivative of tan is secant squared, that's why it's okay.
So this is our wisdom that we need to have.
Our
I'm
discussion.
not sure it's the wisdom, but this is the key to unlocking the door to now start trying to gain that wisdom.
Wait, what? It's not the wisdom yet?
This is like the truth.
This is like the wardrobe.
I'm not sure if wisdom totally comes until you have experience with it. Otherwise, it's just knowledge.
Like you're walking through the wardrobe and then you get to
It's just knowledge.
Oh my.
Because, I mean, if you just take the quote at the back of the room, which is not necessarily like Bible truth, but wisdom is knowing the right path to take. Wisdom is being able to look at one of these guys and being like, hey, I know who you is. Oh, D. Oh, that's going to work nice. Let's go. To some extent, you guys just are seeing like there's a thing called U's and DU's, and sometimes it's helpful. I'm not sure you will always know the right path to take. Does that make sense?
The path to the dark side.
Why? Oh, sorry. Let's hands up. Somebody wait. It's time for us to see what if U prime perfect. What if U prime doesn't fit quite so nicely? Oh, no. We have the tools. This whole, pause. Dx equals, this is me setting you up for success in the next page. Right here. This and this. Me setting you up for success. Here we go. Ready?
Okay, let's do it.
I want you to figure out who you is. Oh, no. Look on the inside.
No.
I'm just saying I like
It looks
why.
nasty. Until you say, oh,
I like why.
let's focus on you.
I like why.
Du is equal to U prime dx.
Ah, sit. Go.
Because U is tangent. Oh,
Oh, no,
she
sir.
has. I've heard her.
It's okay. She's just breaking out of her shell. She's feeling more comfortable.
I thought you still have PE together. I heard her yell there.
Okay,
During
U.
volleyball.
You, Miss D, that's disgusting.
Oh, come on.
Like every
There's a life lesson in here. You look at it, it looks nasty, so you break it down and figure out what the priority is.
But I've gone to the point where
Could be
I
running in my
but
punch. There could be
there's a square root in my way.
But there can be a conflict. Very clever.
I didn't have a friend.
Who's you?
One
One
plus
plus
two.
two.
Yeah, okay, see?
That's what the hard
Yeah, that wasn't that
That's
bad.
like the easiest.
Who's the you?
part. One foot. Y.
4y. And then times dx, which is dy. Is that okay? Ah, because the derivative of 1 is 0, and remember derivative, not integral, you bring down. You bring down the power, so 2 times 2 is 4, and then n minus 1. It's okay, I know, integration, you like go up, but derivative, you come down. I know. It's been too long since we've done derivatives. So again. Wait a minute, you have to get your key to success. Your key to success is get dy alone, because he's the guy who's always there. Just waiting to be plugged in for. So I get du over 4y. Oh, you did that. I'm saying that I set him up for success because he knows what to do when I haven't even taught it yet. The rest of you guys, if you just follow the system, it'll work out just fine. Why? dy is waiting to get plugged in for, so go plug him in. The u, well, you got him from somewhere, so go plug him in where you got him from. And then see what's left. So we have the integral of y square root of u times du over 4y. What cancels out? Why am I saying that u prime didn't fit perfectly? Why am I calling this when u prime is off by a constant? Because what is left over? A constant. There is a 4 left over, but that 4 is left in the denominator. Okay, something key that's going to mess you up. Can you write an understood 1 with the du? Not all the time, but at least for right now. There is a 4 left, but it's in the denominator. What is my coefficient right now that I could move to the front if I wanted to? 1/4. What can I do with any constant that's being multiplied?
Take it outside.
I can bring it all That's just a step of rewriting. Now pause. If there was a variable, have we ever pulled out a variable from an integral?
No.
No. That is
That's
completely,
too
utterly, thoroughly illegal.
What am I killing?
Integration. Okay, so how do I finish it off?
Easy peasy lemon squeezy.
Oh yeah, all I have to do is remember that I'm adding 2 over 2, which is 3 over 2, dividing by, which is multiplying by the reciprocal, 2/3, plus c. And then I can just say f, multiply that by 1/4, which ends up giving me a 1/6 times who to the 3 halves?
My mental math.
1 plus 2.
Thank you. Dun, 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 dun. Oh, nope, 3 halves.
3/3.
I know. Dun, dun. My question is, did anything change?
Nope.
No. I set you up for success by always solving for the dx or solving for the dy or solving for whoever is always there no matter what. What was not there this time? The 4. But did it make a problem? No, because I solved for who was there. I plugged that in and I saw, oh, there's an extra constant. No big deal. Constants come out. Constant coefficients, I should say.
I don't like the next question.
Why?
Well, more numbers, and there's a lot of X's.
But if you knew your trig rules really well, you would realize that secant tangent isn't scary because I know his antiderivative. I'm just going for the good old fashioned 5x cubed.
Will there ever be more than just a B?
Oh, no.
I don't want that.
This level of calculus, we will not have u's and b's. That's calc 2. But we might have messier things happen when we try to do u sub where not just constants are left over and it's called integration on track and it'll be fun. Bye guys, see you later.
Okay.
I love track.
You're gonna take these.